Hello, everyone. Yeah, this is Wang from NVIDIA. Yeah, I'm mostly an open source developer working on the vGPU side for years. So today we're going to talk about this upstream solution of NVIDIA vGPU. Yeah. So yeah, so this would be our agenda. Agenda is like we're going to go through the software architecture and also like like the components inside all the each part of the piece of the software. And I will go through the process of vGPU creation as an example. So to explain you what happens in the patches I sent last night. And after that, so we will go through with the status of the patches to mostly help you more to get deep dive into the patch. And then like some references, so where you can like find the code and demo videos everywhere everything you need to reproduce the stuff in the demo, like that. Okay. So yeah, so the first, what is a vGPU? So basically, the GPU is like you can share like one physical GPU among multiple VMs actually to like each VM see like, okay, I have a vGPU, so I can use it as ordinary TPU. So it's built on SR-IOV. SR-IOV like with the virtual function means like each VM we can have a virtual function. So and then like it has naturally like a resource partitioning and also performance partitioning, right? And it supports all kind of workloads, 3D workload, CUDA, and all kind of workload, the physical GPU support. And then full management features, like for example, we know like line migration and VM suspend resume. So this is like something must to have right in the cloud service. So and the guest OS, so support Windows and Linux. So let's take a look on the architecture here. So the proposal of the software architecture here is like, I think for the upper part, I think folks should be much familiar, right? So this is the like QEMU you're running, I guess, and they're like running like Linux VM on Windows VM. So in the core part is the Nova Core driver, so which is like the core driver provide all kind of service. Actually, the the upper part, we call it like upper part driver actually required. So services like allocating GPU memory, allocating submit channel. So we will go into the details later. Yeah, and then the right part is the core part is the NVIDIA vGPU VFIO driver. So it has like functions like act as a vGPU as like VFIO drivers, and they also manage the vGPU lifecycle, like vGPU creation, destroy, all the stuff. So and in the lower part is like your physical GPU. So it's like the the GSP, the GPU system processor, and also like your virtual function, so which you can pass through into a guest. Yeah. So the VFIO vGPU driver. So basically, its components. It has like several components here. So in the left part, so mostly like there would be the interfaces for the user to select the vGPU types. Like the vGPU actually is defined as a resource combination, and it's defined as vGPU types. So we will talk about that later. So, but you have to select what kind of vGPU you want to create it. Yeah. And then like there would be the the core driver events chain, because we have already been talking about the core driver who provide all kind of services the VFIO driver need, right? So there has to be components in the VFIO driver actually talk with them. And then in the right part, so mostly this part, this is mostly like the VFIO operations. So which means like any VFIO device driver, they should provide all these like control interfaces, yeah, for the QEMU to be able to use it. And in the core, there are the part of the vGPU lifecycle management, which is the GPU resource management and the vGPU bootstrap and vGPU management RPC. So I will go through each piece in details. Yeah. So yeah, and also I put the file names there. So if you take a look at my patches, and then you will definitely notice like which components is in like which files. So yeah, so by going through this vGPU creation, then we can like deep dive in each component actually. So the first step of the vGPU creation is like you have to select the vGPU type. And then what is the vGPU type? vGPU type is actually we talked about that is like the fixed allocation of GPU resources, like the guest, like how much GPU memory you want to allocate to the guest, and like how much like a virtual display head you want to allocate to the guest, and like the bar one length. Yeah, because different vGPU they have different bar one lengths there. And for selecting the vGPU types, mostly like there's an interface in the sysfs. So which means like you can open it and then query, okay, what kind of vGPU types I can create it. Yeah. And then you will be able to select it by, echoing the number of the vGPU type there. And then, yeah, and then you're ready to go. Like you can open the device, the VFIO device, and then you got it. Yeah. But thing is like you must select the vGPU type before create the vGPU. Yeah. And then the vGPU meta file. So we get some feedbacks like, these vGPU types are super large. We better not to hard code it in the kernel. So in the arcv1. So now we move all the vGPU types to the vGPU meta file. So which is actually loaded by the vGPU VFO driver. And then after you load it, then you will see, okay, what kind of vGPU types I can create it from the sysfs interface. So we support RTX 8000 EDA workstation vGPU so far. So that the vGPU meta file you can actually get from the links I showed in the cover letter. Yeah. So after you put it there and then driver load it, then you will see the vGPU types you can create it. So and then the next step. And the next step is about allocating the resource for the vGPU, because you have already selected the vGPU, right? And now it's like the things have been settled, like how much GPU memory you're going to allocate to the guest, how much submission channel you're allocated to the guest, and as VFO driver, we also need some resources per vGPU to do the management work and all these initialization things. So here's the list about required vGPU types, required vGPU source we need to allocate per vGPU. So the guest resources we have been talking about that. Guest submission channels, guest GPU memory, and there would be also like the vGPU management heap memory, so we can talk, to the GSP through the heap memory, and also the GSP command memory. So because we need some kind of buffer to issue the GPU workload to scrap the frame buffer memory, which you can see here. Yeah, this is to avoid, like the information leakage between different vGPUs, right? You create this vGPU and then use this part of the memory, but when you create the next vGPU, you allocate the same memory, but you need to wipe everything inside, and this cannot be done by CPU because, well, it takes like seconds, right? It's unacceptable. Yeah. So, and also we need some driver channels for the VFIO driver actually to issue this GPU workload there. And after you get the submission channels and the GPU memory, then the GPU memory is being wiped, and then you also allocate the vGPU memory to manage heap, and then the resources needed by this vGPU is successfully allocated. Yeah. And then the next step would be like you are now you get all the resources required, right? And everything has been settled, and you get everything from the core driver you need. Yeah, and now it's like you have to register your resource to the GSP. So all the allocated resources are bound to this vGPU will be registered. For example, your guest memory and your submission channels are allocated. So yeah, and then all these registered resources will be configured to the hardware unit to make sure like there will be hardware guest resource isolation. And then this vGPU management RPC will also be initialized. So yeah, it has like multiple functions. So first is like to send the configuration of this vGPU to the GSP. And the other is like it will be later used in the line migration and all the stuff to control the vGPU status. Yeah. So, and then after Bootstrap is done, then you just send the config parameters to the vGPU. So that also you can find from my code. Yeah, and after this is done, so the vGPU functionality is ready, which means like the virtual function behaves as expected. Yeah. So yeah, and then the status. So we actually send the patches actually on last year September. So which actually like we get a lot of feedback, and that is based on the NVKM. NVKM is a driver written in C. So that was a driver actually previous from Novo. Yeah, and also we have some kind of split model driver, actually separate them into two parts, and then one part is core driver, the other part is the DRM part. Yeah. And there's a lot of new changes in the new patch series I sent last night. So first we switched from NVKM to Nova Core. So for Nova Core is a new like GPU, NVIDIA GPU driver written in Rust. So yeah, and then these patches I sent actually they are based on the Nova Core. So and pretty much like we're going through these new areas like a C driver module calls to the Rust module in the kernel. There's a lot of leftover need to be done, I think. Need to work with the Rust community. Yeah. And then this RFC also support the multiple vGPU. So because in the first RFC actually, so we only, for demonstration purpose, we only support one GPU, but this one we support multiple. Yeah. And also like the code, you could find the C workload submission for memory scribing. The implementation of the sysfs to select the vGPU, and also like you can download the vGPU type file from the link. Yeah. The first RFC actually doesn't have any kind of debug interface. So now we have the debug interface, which means we can actually trying to handle more like the bug report things actually. Also like there's feedback from Greg KH said like we need to cope with PF driver event flow because there would be admin to unload the PF driver thing. So you should actually cope it instead of locking it. So there's like this PF driver init handling now. So if the user want to unload the PF driver, so we'll cope with it. Also tested on Windows 11 VMs. Yeah. And yeah, so this is mostly for the folks actually who want to go through the patches and want to find some pointers. So there's one patch set actually. The first patch set I put it here is about introduce very basic, much like the framework of the vGPU lifecycle in the VFIO driver. Yeah. And for the vGPU type uploading, and also you can see it from the third patches, which you implement actually the, like extract the vGPU type blobs from the meta file. Yeah. And for the GPU resources, we talked about like, allocating everything there. So it's actually from the patch 4 to patch 8. Yeah. And submitting GPU workload to core drivers, it will be in the patch 12. Yeah, but yeah, so it could be, and the Nova Core actually currently doesn't have this submission thing yet. So yeah, the code is still there and tested with NVIDIA. Even notifications from the core driver and also the VFIO operation, the front-end interfaces you can find in the maybe the biggest patch, NVIDIA vGPU variant driver there. Yeah. So yeah, and then here you can find the the demo videos and all the stuff you want to reproduce my environment. Yeah. So for the demo, actually, I prepared a small demo video here for folks to take a look on what the POC running. So yeah, so this is demonstrating like two, so this is not project to the screen. So maybe you can take a look later on from the cover letter. Okay, so any questions? No? Sorry?
What's the status of the Nova core?
Oh, okay. So the Nova core has been merged into Upstream, but it's pretty much very basic, initial stuff there. So I think soon it's going to be able to bootload the GSP firmware. Yeah, but still a lot of stuff we're missing there. So in my repo, actually, you can see a lot of Rust code I write there. So for the VFIO driver, but it's not going to be the final picture yet. Yeah, so it's still work in progress. So it's pretty much basic right now. Yeah, but yeah, a lot of progress, I would just say. Yeah, from NVIDIA. Yeah. Any more questions? Okay, good. So if there's no question, go ahead. You mean Windows VDS? Okay. Yeah. I'm aware of the VDS. Yeah. So I think that might be go through the product feature thing. I think for me, I think I haven't been aware of the status of that. Like how it's connected with the yeah. It's kind of PV like PV Windows virtualization thing actually. So I think it's not totally attached to the vGPU itself. It's something like very common from my perspective, I think. Yeah. Yeah. That is a valid question. Like, sorry, I have to repeat this so that this will be recorded. So like, I think your question is more about like, what kind of vGPU matrix this will be support, like how this is going to move on. So I think it's heavily depend on the Nova core development features, right? So first, if you want to, let's say if you want to enable Blackwell, right? So all the core services, enumerations, initialization have to be there in Nova core first, right? And then second, because the interfaces between Nova core and the VFIO driver are quite generic, because those interfaces will also be used with Nova core and Nova DIM, right? So I think for that part, there would be so much gaps because it's not device specific, right? So I think it's totally depend on the Nova development, I would just say. Like currently, I think they are able to run it, but a lot of things are missing, right? So, yeah. More?
Another question from SR-IOV is I want to know the software of the wheel that is upstream as well as the wheel model that we are error. Because that is that which will help. So actually, I think for the result, very different.
Oh yeah. Well, I think the host actually the host behaves a very small part on this actually. I mean, you can see like if the vGPU is correctly configured, everything goes to the guest. Actually, the host doesn't have so much things involved with that, right? So for your question, I think it's more like the different features of the vGPU. I think from the upstream perspective, actually we have all the parameters here. actually like configurable parameters here. Yeah. So which basically means like from the old part, you have everything and just say. And the guest part, I think, well, I have already mentioned also in the cover letter, you can download the Linux driver and try it. Yeah, but I mean, this is pretty much like just the first step. I understand your concern and question, but it's pretty much the first step. And a lot of co-work need to be done, like mobile and also a review for these patches and interfaces. So yeah, cool then. So no more questions. Thank you so much for your time. Yeah.